Hello everyone, welcome back again to my channel. Today we're going to talk about Tech Talent Recommendation Engine. This is the project for the class of Modeling for Structured Data Recommender System. Well, what we're going to talk about, the first one is the problem breakdown, the second one is the proposed recommendation engine, and the third one is the implementation and experimentation, and the last one, of course, is the calculations and future works. Okay, let's go to the number one, is the problem breakdown, where we identify the gap in efficient tech talent acquisitions. Well, the challenge we are trying to face is the inefficient tech talent acquisitions. The challenge is in acquiring suitable tech talents in the current industrial landscape have been well documented across various platforms. Here are some of them. Well, the challenges are one of them is the technological displacement, where automation and AI are taking over the human tasks across various industries. The second one is the continuous skill development, where there's a need for ongoing learning and skill development to stay relevant in the evolving job market. And the third one is the great attrition of or resignation, where many individuals are quitting traditional roles, leading to a structural gap in the labor supply and mismatch between talent and demand and supply. The fourth one is the changing work preferences, where the pandemic has altered the job and the life priorities, with workers valuing workplace flexibility, mental health support, and meaningful work differently. And the fifth one is the skill gap and finding the qualified candidates. A significant challenge is the skill gaps and the difficulty in attracting qualified candidates, especially in tech. And the last one is the mobility between industries, where employees switching job upon changing job, making it challenging to fill vacancies in similar talent, creating talent vacuum in certain sectors. Well, now the proposed recommendation engine, where we present the ML engine for precise candidate profiling. What's a recommendation engine? Well, recommendation engine is basically an engine that filters and predicts the most relevant items for a user based on preferences. In our context, it's AR, it's for HR. It researches matching candidates' profile with job requirements. And the engine learns from the data, which includes candidate skills, experience, and job descriptions. Well, what we are going to do here is by using matrix factorization technique, a sophisticated approach to a recommendation system, which works by decomposing the candidate job matrix into factors, and then these factors represent latent features of candidates and jobs, well, such as skills, experience level, and so on. The goal is to find patterns that help to predict candidates' suitability for the role, even with limited informations. Well, the algorithm we are trying here is there are two algorithms here. The first one is the alternating least squares, and the second one is the gradient descent in matrix factorization. Well, how do we really do matrix factorizations? Well, let's say on the graph over there, user home matrix is the user matrix based on each home they have. Well, in our case, the rows is the talent or the user, not really a user, but the talent that the HR want to take or the HR looking for, and the home is the skills that they need. Well, we got this matrix from the products of the user matrix times the home matrix. Well, in our case, is the talent matrix and the skill matrix. Well, we times those two matrix into one single huge matrix, which we call matrix factorization techniques. Just like that. It's simplified version. All right. After we have those matrix, what we are gonna do? How do we find the similarity of the ones that HR are looking for and the ones that we have? Well, after candidate matching via matrix visualization, we employ question similarity to rank the candidates. The engines compare the skill set factor for each candidate against the factor of the job requirements. This technique allows us to effectively score each candidate against skill set in question, and the candidates are then ranked based on their similarity scores, presenting as the top match to HR. Well, quotient similarity measures the quotient between angle of two non-zero factors in a multi-dimensional space, which in our case, the candidate skills profile and the jobs requirement profile. It ranges from -1, which means exactly opposite, or the one, or it's meaning that it's exactly the same, with a higher score indicating the greater similarity. Well, what about the algorithm? Well, we're going to talk about in the next video of advanced machine learning class. All right. Well, this is the method that we are going to use to evaluate our models. The first one is the MSE. well, where the MSE measures the average squared difference between the estimated values and the actual values, and it emphasizes a large error due to squaring its term, which means it's sensitive to outliers. And the second one is the MAE, measures the average magnitude of the error in a set of predictions without considering their directions. It's linear score, which means all individual differences are weighted equally in the average. Well, this is our model workflow where we use the data processing, where we process our raw data set. And the second one is the matrix encoding, when we encode it to become a matrix. And then library creation, where we create our own ML from scratch library. This is for the advanced learning class. And then we go to the model training and evaluation, where we train our model and evaluate it. And the last one is where we do API creation and containerization, where we have the API and front-end creation and then containerize them. All right, this is the implementation experimentations where we see the outlines of the engine's development and performance metrics. Well, this is the exploratory analysis. Well, this is only some of the data visualization, where if we see the first graph that we have is the data exhibits a concentration of experience among developers, primarily in the 2 up to 20 years range, indicating a diverse pool of mid-level seasoned professionals. A notable peak is observed at 10 years, suggesting a common career stage where developers might seek new opportunities. Well, on the second graph is the outdated, so a predominance of full stack developers followed by back-end developers, which reflect current industry trends. The prominence of these roles could influence our recommendation engine to favor candidates suited for this position. Well, as you can see, the most position we have here in order is the full stack developer and the back-end developer. Well, which might indicate some of the recommendation might tends to choose that roles. This is our model matrix comparison. The ALS model demonstrates a significant reduction in error as the number of factors increases, which indicates a better fit for our data with more complex model. The downward trend in both MAE and MASE suggests that the LS model effectively captures the underlying patterns in the data as it becomes more nuanced. In contrast, the gradient descent model does not exhibit the same level of error reduction, possibly due to randomized starting point used in the algorithm. This could indicate that for the given dataset problem, gradient descent may not be as effective in capturing complexity of candidate job matching. We'll talk about this algorithm in the next videos of the advanced machine learning class. Well, this is the demonstration of the tech talent recommendation engine, where we choose the age ring of the candidates, the HR wrong, work arrangement, and then the education level, and then what the role the HR wants, years of experience. Yeah, we can choose that, and then we can choose the programming language that we need for the candidate to have. The databases, MongoDB, MySQL, PostgreSQL, and etc. And then the cloud platform that the candidates have been using, like all of that. And then this is the web framework. Maybe if you are seeking for a front end or back end developers, other frameworks like Pandas, Scikit-learn, TensorFlow, and then developer tools. If you want to find candidates who have similarity with these tools, development environments in your company, like IPython, RStudio, Vim, or so on, or Visual Studio Code even. And the next one is the operating system, where, well, maybe if your company using like Ubuntu, Windows, or WSL, you can choose that too. Well, this is the collaboration tool like Miro, Utrack, or maybe Microsoft Planner, and so on, Jira. And then the last one is the communication tools, like what communication tools does your company use, and so on. And then we can hit the button recommend to see the recommended candidates. Well, as we can see, we got these recommended candidates based on the requirements that you have input to our engine. That's their information, what language they have been worked with, database they have been worked with, and so on. Yes, and that's how our recommendation engine works. Alright, the next one is the conclusion and future works, where we see the summary and the future enhancement plans. Where the conclusion is, for number one is the agent creations, where we develop a cutting edge tactile recommendation engine to streamline HR processes. Data utilization leverage the comprehensive Stack Overflow Annual Developer Survey 2023 for our data-driven insights. Library development, we built an in-house ML from scratch library to facilitate custom matrix factorization techniques. Algorithm iteration, we refine the recommendation logic by iterating between ALS and gradient descent algorithm. The next one is the system integration, where we establish a full stack solution with both front end and interaction with back end processing. And containerization, where we employ Docker to containerize the application, ensuring ease of development and scalability. And our future works, of course, is the feature expansions, where we aim to incorporate additional features to capture a wider spectrum of candidate attributes, dataset enhancement, of course, to seek out richer dataset for deeper insights and more precise recommendation capabilities, model evolution, explore cutting edge modeling technique for enhanced model accuracy, of course, library upgradation, where we plan continuous improvement to the ML from Kiss library for broader algorithmic application. And the last one is the UI refinement, where we commit to improve the user interface for an optimal user experience. Thanks for listening to me. See you on the next video. Bye bye.